Welcome to our video on TensorFlow Lite, where we'll get a brief look at TensorFlow's new solution for mobile and embedded devices. First, we'll go over the basic ideas behind TensorFlow Lite regarding what it is and how it can be used. Then we'll see the typical sequence of tasks required for one to take an existing TensorFlow model and get it inside a mobile application. Note that TensorFlow Lite is still very new and changing rapidly. In just the past few days that I spent preparing the video, new tutorials have been uploaded for TensorFlow Lite on TensorFlow's master branch, and substantial functions have been pushed in just the past couple weeks. Unfortunately, at the time of the video, I do not have the hardware needed to build and run an application. I have a Linux machine and an iOS device, but in order to run the apps you build currently, if you have an iOS device, you must have a Mac. Similarly, although I can create and build to completion the Android apps, I can't run them because they currently do not work on the Android emulator. You actually need a real Android device to run the app. Because of this, I'll only be able to provide links for learning more about TensorFlow Lite since I currently do not have access to the right hardware for running any kind of demo. Here we see a diagram taken from the TensorFlow Lite talk of the 2018 TensorFlow Dev Summit, illustrating the main components of TensorFlow Lite. The first component on the left is the converter, which converts your saved models into the TensorFlow Lite format. This is the flat buffer format. Flat buffers are very similar to the protobuf format, but are optimized for memory, and that's very useful for mobile devices that have more memory constraints than the typical machine that neural networks are run on. TensorFlow has been releasing more and more utility functions for easily converting your saved models, but again, most of those are still only on the master branch and not officially released as of the recording of this video. So I won't be able to show an interactive demo of them here since they are still not officially released in any of the TensorFlow releases. Next is the interpreter core, which runs on the mobile device itself, and the operation kernels and hardware acceleration to optimize for faster execution on mobile devices. As you may have guessed, the general workflow is pretty straightforward. Starting with your trained TensorFlow model, you pass it through the converter to get the flat buffer format. Then, depending on the type of device you'd like to put the application on, you move to the appropriate API. For Android devices, you'll be working mostly with the TensorFlow's Java API, and maybe a little C++. For iOS devices, you will be using the C++ API, and for things like Raspberry or Linux, you have much more flexibility, I guess, for which API you want to choose. That's all for our quick introduction to TensorFlow Lite. Let's recap the topics we saw in this section. First, we got an idea for how development in a production setting can differ from a research or tinkering setting. Then we worked through some examples using TensorFlow's C++ API. After that, we learned about TensorFlow serving, that uses the C++ API and gRPC to allow for easily serving our TensorFlow models. Finally, today we got some exposure and links to the brand new TensorFlow Lite solution for mobile and embedded devices. As always, make sure to read through the links here for an in-depth look at the topics covered today. In our next and final section, Miscellaneous Topics and Course Summary, we'll go over a handful of interesting topics that were specifically requested for this course, and we'll wrap up by taking a look back at all the material we've covered throughout the course.